Alright, well, this is chapter 2 in Planetary Geology, part 2 of 2 parts. Excuse me. I'm going to continue on talking about the moon. We talked about our location in the universe, we talked about the tilt of the Earth, the precession of Earth, the seasons, how we look at the sky, and how we identify objects in the sky using zenith, meridian, cardinal coordinates, and the angle of which the distance from the horizon up, the angle, excuse me. Alright, now we'll just move on. In the final portion of chapter 2 in your textbook, we'll talk about the moon. Alright. And for your slides, it is slide 52. Okay. So moving on, the moon. We have several phases of the moon. You've probably heard of new moon, full moon, but maybe you haven't heard of the other phases of the moon. There are 8 in total. If you just remember one phase of the moon, you can remember all 8 phases of the moon. So what I start with, typically, is the new moon. The new moon is a moon that's overhead in the daytime. That's a new moon. You don't see it because the sun is so bright it blocks out everything else in the sky, almost everything else. So a new moon, like I said before, all celestial objects rise in the east and set in the west. Well, same for the moon, generally rises in the east and generally sets in the west. But the new moon rises approximately 6 a.m., sets approximately 6 p.m. If you remember that, then you can remember each phase of the moon in its lunar month. 8 phases. That's the first. The second phase is the waxing crescent moon. These first half of all the phases in the lunar month are waxing phases, and the second half are waning phases. So the first phase after a new moon is the waxing crescent moon. Notice in the figure on the slide, the light is shining on the right side of the moon. So when you're looking in the sky and you see only a portion of the moon that's lit up, and you see it lit on pretty much the right side, it's not always that perfect like that in the picture. But if most of the light is on the right side of the moon, then it is a waxing moon. Then you have to figure out how much light is on the moon. If there's just a small fingernail type portion like on the figure, then that is a waxing crescent, and it rises at 9 a.m. and sets at 9 p.m. So from the new moon to the waxing crescent, you'll notice there is a 3-hour shift of rising to setting. If you remember, all I have to take note of is what I said, the new moon. The new moon rises at 6 a.m. and sets at 6 p.m. And guess what the waxing crescent does? It rises at 9 a.m. and sets at 9 p.m. So there's a 3-hour shift. So the next phase after the waxing crescent, what do you think is going to be the rise and set of that phase? Well, if the waxing crescent rises at 9 a.m., the next phase, being the first quarter moon, rises at noon and sets at midnight. Okay, and the first quarter moon generally indicates that only half of the moon is lit, the right half of the moon. It is not called a half moon, contrary to what you've probably heard of before, but that is not a phase of the moon, half moon. First quarter moon is a phase of the moon, and it is a waxing moon. Next phase is the waxing gibbous. It rises at 3 in the afternoon. In the afternoon, sets at 3 a.m. in the morning. Next phase is full moon. Again, 3-hour shift, rises at 6 p.m., sets at 6 a.m. Complete opposite of a new moon, if you haven't noticed, and it's also the halfway point in a lunar month. The next phase after the full moon is a waning gibbous, which means it rises at 9 p.m. and sets at 9 a.m. Third quarter moon rises at midnight, sets at noon. Third quarter moon again is covering half. The sunlight is covering half of the moon from our perspective on Earth, covering half of the moon. And it's the left half. Have you noticed that? The light is on the left. And then the next phase after that is the waning crescent. It rises at 3 a.m., sets at 3 p.m. Notice the left side is of fingernail type. Left side of the moon is a waning crescent. And then back to 3 hours later, the next phase. The 3-hour shift in the next phase is again the new moon. So if you start with the new moon, rises at 6 a.m., sets at 6 p.m., and then you wax and wane as the moon orbits the Earth, and the lady in the picture is the Earth, then you'll know that that is why we see the sun the way we see it. Alright? And that's my dog, if you hear my dog. Sorry. Okay, moving on to another slide. Slide 55. This slide just shows the phases of the moon in a different way, just lined up. And notice that a lunar month is approximately 25.5 days. You know, our Gregorian calendar, Roman calendar, uses about a 30-day month for the most part. And the reason why it doesn't use a 30-day month every single month is it's not exactly correct. It has to readjust throughout its year to compensate for the 29.5 day cycle. Okay, it's not exactly 29.5. But you notice in that on that slide that in the waxing moon, the waxing moon, the moon is visible in the afternoon and the evening, gets fuller and rises later each day. The waning moon is visible in the late evening and morning, gets less and sets later each day. So the next slide is that if it's 9 a.m. in the morning, you look up in the sky and you see a moon with half its face bright and half dark. Okay, not sure which half, right? But you do know it's 9 in the morning and you see the moon half its face bright and half dark. Okay, so you know it's either the first or the third quarter moon, right? So, in the first quarter moon, it rises when? At noon. So we don't see it at 9 a.m. Right? So what do you think the answer is? It's a third quarter moon. Because in the third quarter moon, it rises when? It rises at 9 p.m. and sets at 9 a.m. Alright? Alright, so moving on to the next slide. The Earth and Moon cast shadows. These shadows are very special, especially when it comes with the alignment of Earth, Moon, and the Sun together. When the Earth passes between when the Earth casts a complete shadow on the Moon, we call that an eclipse. And in this picture on slide 58, when the Moon is actually completely covered by the Earth's shadow, we call it a total lunar eclipse. This happens especially, it has to be a full moon, first of all, in that phase. And also the Earth has to be aligned with the Sun. So, if you look at this figure on slide 58, the Moon falls along the exact ecliptic plane where the Sun is shining on the Earth. See, the Moon's on the opposite side of that same plane. Okay, so these lunar eclipses occur at the full moon in the next slide. But you can find variances of a lunar eclipse during a full moon. It can be a penumbral, which the moon passes through only a portion of the shadow. You can have a partial, which you have part of the moon in direct cast of the shadow, and then you can have a total lunar eclipse. We call that a blood red moon. For you biblical scholars, for you prophetic people, it's called a blood red moon. But in science we call it a total lunar eclipse, where the moon is completely inside the umbra of the Earth, as the picture portrays. We also have solar eclipses in a similar configuration: Earth, Moon, and Sun. Solar eclipses occur during a new moon. Okay, not during a full moon, during a new moon, because the moon is what's causing the eclipse. The moon is between the Sun and the Earth, and the moon is a lot smaller than the Earth, so the shadow that it casts on the Earth is very, very small compared to the lunar eclipses. So a solar eclipse casts only a shadow only on small portions of the Earth, very slim portions of the Earth, as the picture portrays. A total solar eclipse occurs again when there's a new moon, when there's a new moon, when the moon is on the ecliptic again, and when the moon is the closest to the Earth. When the moon is the closest to the Earth, it's the best time you can get a total solar eclipse. Now, that total solar eclipse is very special. That total lunar eclipse is very special. They only occur, they are rare. They occur very rarely. A total solar eclipse blots out the Sun. A special, even more special solar eclipse is called an annular eclipse. The moon's umbral shadow doesn't quite reach the Earth. That's called an annular eclipse. Well, we see it blotted out, the Sun blotted out up in the sky, but it doesn't quite reach the Earth. It's kind of a special time. We have some very special moments like this occurring in 2014 and 2015, and I've already brought that to your attention. I just want to make sure you're still aware of it. Okay, we have eclipses only during these times. In the next slide, just wanted to bring it up to your attention again. The alignment has to be along the ecliptic plane, and there has to either be a full or a new moon. Moving on, there are two. Okay, moving on to the. I have skipped several slides just for this lecture so that we don't have to spend a lot of time on YouTube. You can follow along on the other slides at your leisure. But in slide 66, we predict solar eclipses, and your book shows you that the eclipses, this seral cycle we call it, occurs every 18 years, 11 1/3 days. Okay, so moving on, the next solar eclipse that when I first put this lecture together was November 28, 2012. But the next lunar eclipse is going to occur April 15th. The next solar, and then another lunar eclipse on October 8th, slide 68. Alright, October 8th, 2014. Alright, can be seen at those special places. And then the next total solar eclipse occurs after that, and then there would be 2 more lunar eclipses in 2015. Very special time for you and me. And we've learned that in this lecture about the moon, their phases of the moon, and how special eclipses are. We'll talk more about the moon as time goes by, but I just wanted to tell you a little story about that. With the ancients, the moon was a very special object in the sky, and there are many objects in the sky that were very special to the ancients. Mercury, Venus, Mars, Jupiter, Saturn, they were all observed by the ancients. The moon is no exception to that. All the planets usually move in the night sky eastward from night to night, relative to the stars as you went up each night and looked at them. But they rose in the east and set in the west, just like all the other objects in the sky. It seemed like they go westward as time went by, as they went up and looked at each sky. But there was, on slide 72, you'll see that there was an anomaly occurring with some of the planets. They seem to be looping. They actually look like they moved backwards from one day or 1 month to the next. And you can see that we looked at Jupiter on the left and then Mars on the right, and there was a loop occurring. And that loop was what we called apparent retrograde motion. We didn't understand it as an ancient. But next slide, 73, explains to you what happens. The Earth is moving faster than Mars, for example, or Jupiter. And because the Earth moves faster around the Sun, it passes up Mars and Jupiter over time. And when the Earth passes up Mars or Jupiter, it laps it. And it appears to people on the Earth that Jupiter and Mars are going backward, when in fact they're not. They're orbiting just like Earth, but they're moving slower, orbiting slower, much slower. Okay, and then moving on to slide 75, skipping some slides. Ancients, Greeks, they rejected this idea of apparent retrograde motion, which is what I just talked about, and also stellar parallax. I will give you this, that I'll talk about this at more depth as time goes by, and we'll just show you this in slide 75, that no, the ancients did not realize that the Earth was orbiting the Sun, and because of that, some stars that were really close to us seemed to move, and that really scared them. They thought it was of the devil, to be honest. God wouldn't do something like that. We'll talk about stellar parallax as time goes by. We know that that's not of the devil. Slide 77, the Greeks knew that the lack of observable parallax could mean one of two things. So the Greeks knew that the stars could be so far away, too small to notice with the naked eye, or it doesn't orbit the Sun. They didn't want to spend much time talking about it because they didn't have an explanation. Okay. So we've learned that just a few more slides here. We've learned that the Sun and the Moon, they usually drift eastward. We call that the apparent retrograde motion. And the Sun, with respect to the Earth, has a stellar parallax. It moves, it orbits around the Sun, and because of that, the Greeks didn't want it. They kind of knew that there was a problem there, but because God was perfect, they did not want to stir the waters. They called it an evil thing that the devil was doing to the heavens, and they did not want to go any further with it at that time. Okay. There are more current events out there, and I will discuss those in class. Okay. However, I have some slides that kind of give you some interesting articles about meteorites that have hit the ground in the last few years, and thought they were pretty interesting. And then there was one slide in the lecture that talks about a near-miss asteroid. This does happen. Whoa! That went by. We didn't even know it went by. And this one near-miss, surprised asteroids make near-miss of Earth. It's a small asteroid buzzed by Earth on March 2nd, 2009, though only real astronomy geeks in the Pacific noticed it. The rock, estimated to be no more than 200 feet wide, zoomed past our planet at an altitude of 40,000 miles above us. So it was a pretty interesting time. And we have things like that, or slam past us, fly by us really fast, many times. Okay. And then there's some other humorous slides in the rest of my deck, just to have a little fun. I usually show those to you and when we're in class together. Alright, this concludes my lecture on Chapter 2, Part 2 of 2. If you have any questions, once again, you can email me, call me, or text me, or wait for class. You may not want to do that. I would not recommend it. Okay, thank you.